Hello, hi, good evening, and all that jazz. It's tutorial time. You might have seen the preview for this a few days back. It's a funky, random, abstract, musical number. So let's have a quick look at what's going on, even though you've probably seen it about 5 seconds ago. I'm just going to shut up. And so on. You get the idea. So that's what we're going for. Something with a bit of colour, a bit of movement, some sound, and we'll react to the sound. Now I've been banging my head against the wall, as I always do with these tutorials. I try and do too much in too short a time, so I'm actually jumping the gun a little bit here. And I've got 2 classes already made that are fully commented. I'm just going to talk through them for the first bit, because there's nothing groundbreaking in them. We've done it before. So these are the starting files you can download from the website. I'll put a link under the video, but I'm going to talk you through them anyway. So here's what's going on. We've got 2 classes. We've got a basic line and a basic circle, and they are the 2 core animations in this project. So instead of me typing them out and talking in a monotone the whole time, we'll just go through them quickly so you understand what's going on behind the scenes, and then we'll stitch them together before we do the musical pulse and various other bits. So the basic circle is the simpler of the 2. Start by importing a few things. We've got the shape class. We don't need everything a sprite can do, so a shape will do. We've got event, because it throws an event of its own or dispatches an event. And we've got the flash tweening classes. Now, if you're more comfortable using tween libraries that other people have made, you go for that. I'm not here to do tutorials on those, but if you understand them, feel free to change these classes. We get into the class. Circle extends shape, and we only have one variable in this, just to store a tween that makes the circle grow. And tweens can often fail, as I've commented there, if they're not stored. If you just make a tween, if that bit wasn't there, we just made a tween, it might work for a few frames, but then because the garbage collector would eventually just get rid of that tween because it's not stored anywhere, it would stop working. So that's why we store it. The constructor for this basic circle takes in a few bits of information which we're going to randomize later on to get the different colors and sizes and so on. So it takes in a radius for the circle, a color, and then the time is the amount in frames of time that this circle takes to grow. All fairly standard stuff, as is the next part where we actually draw the circle. So we start by setting a colour which is passed in, so we just begin fill with the colour, and then we draw the circle right in the middle of the shape, starting from 0, 0, with a radius specified there. Then we stop drawing, really simple, so really just one line of drawing stuff. Don't even have an outline. And then we tween the circle's scale, or we tween the scale X at least, and then a bit further down we do the scale Y to match it. Using one of the easing functions, I've gone for back.easeOut, which means the shape of the circle bounces back, but feel free to change that. You could go for regular, strong, elastic, just experiment with it. We've then got the starting value and the end value for the scale. So it starts at 0 scale, finishes at 1 scale, so it comes from nothing to full size, and it takes the amount of time that we've passed in. Hopefully this makes sense and you're getting something out of it without me mindlessly tapping away. We then add 2 event listeners to the tween. The first one is to update the scale Y every time the scale X changes. So when this tween updates, so we get this motion change, when that is changed, when the tween changes, we update. And update basically just tells the scale Y of this circle to match the scale X. And because the scale X is being tweened, it grows all the time and shrinks back at the end. The second event listener just waits for the finish. So when the tween is complete, we have this function to finish the circle. And that's where we dispatch an event. And that's one I've actually made up there. So I've just made a new event and given it a type of shape complete. And we need to remember that because we're going to react to those in our animations when we start stringing these shapes together. So that's the basic circle. Hopefully that made sense. Feel free to post questions about it. If not, I'm just going to save it. The basic line has a little bit more to it because it's a bit more complicated to animate a line than it is to stretch a circle. So start by importing shape event and the tweening stuff. We also have a point because we're going to animate our line towards a set point. We're extending shape again. We don't have any children in this shape object, so we don't need to be a sprite. Make a tweening variable again for the same reasons as mentioned earlier. We also make other variables to store the end point, so where this line's going to finish. The line's going to start from 0, 0, and then we specify an end point. We have a colour and, and a thickness, and they have to be stored because they're not just used in the constructor anymore, which in the circle class you can see that we don't use the colour or the radius or the time anywhere outside of the constructor, so we didn't need to store them, whereas the line will when we get down to it. The constructor takes an end point, a line colour, a line thickness, and a time, and they all have corresponding variables with the exception of time because that goes into the tween. Weird word. So all we do is store the necessary information when this basic line is created. So we just use the class's variable end to store the end point that was passed in. That's all that's going on with these three lines. We're then doing a tween, but this time we're not actually tweening a property. In the circle we tweened the scale x property of the circle. In this tween we're actually just tweening nothing, so we can react to the tween's position rather than to a property that's been tweened. We don't even have to tween this. We could probably get away with tweening nothing, but it does no harm. I've used a different type of easing this time. I don't want the line to grow beyond its range and come back, so I've gone for a regular ease. The progress of this tween will again be from 0 to 1, which actually simulates how far through the animation it is. So 0 is the very start and 1 is 100% complete. And time is passed in again, so the amount of time the tween takes is passed in. We then have same two event listeners from the circle, so no change to those two lines. Two functions again, but this time the contents of the functions are different. So the update function this time, instead of just stretching the line's scale y to match the scale x, we're actually drawing the line from scratch every time. So we start by clearing the graphics. We then set the line style based on the thickness and the colour, which is why we had to store them. Move back to 0, 0, just in case we're not there. And then we draw a line to the end point times the tween position. So the tween position starts at 0 and tweens to 1. So in the first frame, for example, tween.position will be 0, hopefully, which means we don't get a line drawn really. And then by the end of it, by the end of the tween.position has made it to 1. So we're getting the full value of end.x and end.y. So that's really the most intricate part of this line class. There's nothing more complicated than that. The finish function is the same again, we just throw a shape complete event. So when both types of animation, both types of shape finish, they throw a shape complete. So yeah, that's pretty much it. They're the two building blocks. I just wanted to run through them quickly before we get into stitching them together. Now it's a bit of a different approach. I feel like I'm not actually doing anything, just talking through two pre-typed classes, but we're getting into the fun bit next. That's the whole point. Let's speed the process along. And I'll see you in part 2. Okay, hopefully by this point you've either downloaded the starting files or you've been through the first part and you've copied the code out. Hopefully understood it as well as we go. I'm just going to rename that starting files folder. I'm going to call it Project 8, just so we know what we're working on. Open it up, so we've definitely got both those classes in there, and I'm going to start my actual project now. So I've got a blank FLA file. Again, you don't have to be working in Flash. This is all going to be code, so Flash Builder, Flash Develop, even just Notepad. As long as you can compile, it'll work. I'm going to put the frame rate up to 60. I want to try and keep it as fast as possible. I'm going to put the size up to match the blog window, so we get the same sort of result. And the colour doesn't really matter right now. We'll probably put something over it before the end of the video. Just get that saved on the desktop in project 8, and I'll call it main. Okay, so we're up and running. Let's just get our first class on the go. We're going to sort of work backwards from, we've got the absolute basics, and now we're just going to have one step up where we chain a few of these together in a little animation, and then we'll have a controller that loops all these animations together, and then something above that that does the music and makes it pulse and rotate and so on. So we're going to start from the bottom and work up. Let's make a new class. And I'm going to call this, let's call this basic animation. So we'll just have a really simple one to get us going, and we'll probably extend from it to make the rest of them. So we'll set this class up in a way that we can reuse it, which we could have done with the basic shapes, and feel free to do that. Go back, put them in packages even if you want to space them out. Change it so that the line extends from the circle and just changes a bit of functionality, so you're getting used to that kind of inheritance. This basic animation though, it's going to be a sprite this time because it's going to contain children. So start by saving it so that my code hints work. And we want to import flash.display.sprite. I'm starting to see why it's better if I just do the code first because I can't spell. We're also going to need a few more bits, we'll come back to that. The class itself is going to extend sprite, so put that in. And there's one main property that all classes in this animation chain need, and it's going to have to be public so that our controller can get to it, or you could do a get function. So you could have this as a private, I'm going to do it public, you could have this as a private variable and maybe lead it with an underscore so you've got an easy way to tell them apart. But mine's going to be public just so I can get to it from my controller, and it's going to be a point. And notice there that it's imported for us. All animations will have an end point. Even if they don't move, they'll have an end point of 0, 0. And that's so the controller knows where the next animation should start from. Enough waffling, let's get into the constructor. We actually don't need to pass any information in, it's all going to be randomly generated inside here, unlike the basic shapes that we've just done. Starting nice and easy, this basic animation is, instead of having all the content in this constructor, going to call another function that we can then override. Because we could, if you want to be, I don't know what the word is because I found bugs this way, but if you want to do it where you add an event listener here, so we can add an event listener and we can use an event.added to stage that will mean this animation does not start until it's been added to the stage. But I've come across a few errors where that actually fires twice and it messes up the animation, so I'm actually going to skip that one, but just bear in mind you could do that. I'll comment it out, put could use, and then you'd override the function that goes with that. I'm just going to have a name, I'm just going to put begin for the function. So we need to make that function, and we're going to override it in subsequent classes, well, in subclasses. So let's make it protected so that we have access to it when we extend this class. Protected function begin. No arguments, no parameters, and no return type, so let's make it void. And in here is where you do stuff specific. Let's put stuff specific to this animation. There will be a few more bits in the constructor there, and every class that extends from basic animation will use the same bits of that constructor. We won't even make constructors in the rest of them. Override this function in subclasses. So by overriding this function, we're basically replacing what it does in different classes. We'll do that after we've set this basic one up, just to get an example going. We'll then override it to make a different animation. In here, I just want to make one circle, add it to the screen, and when it's finished, we'll finish this animation off. So we're going to make a variable to hold it. Let's save our circle. And it's going to be a basic circle equals new basic circle. Open brackets, and we get prompted there for the information that makes our basic circle, starting with a radius. So I'm going to generate random numbers here, but I want a minimum base. So let's say at least 30, and then we'll add a random number, so math.random times another 30. So it could be anywhere between 30 and 60, or 30 and 59. Depending on the way it was set up. We then want a colour. I'm just going to drop down a line so I don't overrun. Random colour, just do white times math.random to get a random colour. Comma, new line, and then the time. Want this to be fairly quick, so I'm going to say at least 10 frames, and then add math.random times 10. Keeping semicolons reflexively. So we're making a new basic circle. It's going to be at least 30 pixels wide, but it could be up to 60. Then we're going to randomize the color, and then we're going to take at least 10 frames, but could possibly be up to 20 or 19, depending on rounding. That's the circle made. We then want to add an event listener to the circle. So circle needs to go in front of that. Circle.addEventListener, and this is where we use the event that we made inside of our basic circle, which was shape complete. I cannot spell. Circle.addEventListener, shape complete, and then we want to finish. So the animation will finish when this first basic circle is finished. Quite simple. We might as well have just had a basic circle as our animation, but this sets up the structure of all of our animations to follow. And lastly, we need to add child circle, so make sure the circle's on stage. Just chuck in a comment or two. When the circle has fully animated, finish this animation. Okay, so this is the most basic animation we're going to have in our sequence, and we're going to override this begin function in all of our subclasses to make different types of animation. We now need a function here to respond to this event listener. This will be protected so that subclasses can use it, but I'm also going to make it final, which means it cannot be edited. So this will be a final protected function. Cannot be overridden, sorry. Once you've made it final, that is it. That is the final way this function will be. And we'll call it finish, because that's what we've told it to be there. And then in here, this could be responding to an event, but it could also just be called manually in some of the subclasses. So we'll give it an event as a parameter, but we'll pass in null as a default value so that we can just call the function. We can just call finish without actually passing anything in. It's not going to return anything. And in here it's just going to throw another event to show that our animation has finished. So we're getting lots of events firing up the tree, up towards the controller, so that the controller can deal with chaining the animations together. So tell the controller this animation is finished. We'll use the same code again. We'll dispatch event, same as in the basic shape, new event, but this time we'll call it animation complete. Close both sets of brackets and we're done. So let's have a quick look then at the entirety of the class there. Put it in a package by all means if you want to organise your classes that way. If you're going to have lots of animations, then it's probably a good idea. Just get some white space gone. We import sprite because we extend sprite. We import point because we're going to store the end point of all of our animations so that the controller knows where to do the next point where to do the next animation from. We then import event because we throw an event and we respond to events, so we have to have that class included. We store the end point of this animation just so the controller can work with them later, and then the constructor, which I should edit actually a little bit. Let's make the point, so we'll do end equals new point. So that's a default end point of 0, 0. Default endpoint of 0, 0. I'm also going to change the blend mode, and that's to stop alpha ugliness. That's for a lack of better term. If you leave the blend mode as normal and you try to fade out an object that has children, the alpha will sort of combine and you get a weird overlapping transparency effect that doesn't look very nice, whereas setting the blend mode to layer kind of deals with that a bit. Gets rid of ugly alpha effects. And then we begin. So this will actually be the constructor of all of our animations. They'll all extend from this class, so they will actually do all of this before they're made. We're then going to override this begin function, which at the moment just makes a basic circle, adds it to the screen, and then waits till it finishes before telling the animation to finish. Hopefully that all makes sense. We're now going to save it, and we're going to make one that's a bit more interesting. So we'll make a new class, and let's call this line animation. Hit OK, and this time we want to extend basic animation. So our line animation is going to take in everything our basic animation can do, and then we'll build on top of it. So let's just save it. We can actually get rid of the constructor, which is a bit weird. It's almost like we're not making the class, but we are, because we inherit the constructor of the superclass there. So we don't need a constructor. The superclass does everything we need. So no constructor, we just have the default from the parent class. But what we're going to do is override the begin function of basic animation to make a different effect. Okay, so we lead with the word override, and then we pretty much copy that word for word, character for character. So copy that, paste it in, and begin our begin function. This time we're going to make a line come out from a particular point, but just before we get into it, let's make sure that we actually have something in this basic animation. So I'm just going to be really messy and do this in the timeline just to see if it works. So in my timeline, I'm going to quickly go to the actions and just add child, new basic animation, and run it. You can see we got a circle very quickly there, so maybe put it somewhere else. Let's cut basic animation out of there, call it BA, basic animation, and we'll actually store it so we can position it. And just do it halfway across, halfway down, and try it again. You can see we've got a circle right in the middle, and it was a different colour this time. Run it again, we get a different circle, keep running it, and we get different circles of different sizes that tween in at slightly different speeds. We might need to make that a bit different, but it's working. We could even go as far as to chain those together by adding event listeners. Well, probably only take about 30 seconds, so let's just copy that. Do ba.add event listener, and the event was an animation complete, and let's do next animation after it. So we need a function called next animation in response to an event, and we just paste the code again. Let's let's make sure we keep the event listener as well if we want them to chain. It's going to throw warnings and stuff because I've got duplicate variables, I think, but I don't know, never mind, different scope. But you can see they chain together and it'll very quickly become laggy because we're not deleting the old one. So I'm going to close that, but it works. I'm going to delete all the code because we don't want timeline code in this particular tutorial. So we know it works, there were no bugs, no errors in that basic animation. We can assume all is well. Here in our line animation, I'm going to do things a little bit differently. I'm going to spawn a circle and then a line and then a finishing circle, all of the same colour, before we go on to the next animation. So we do need to store a few things in this, namely the colour of the whole thing. So let's make a protected var called colour. That will be an unsigned integer, so we can have a colour in there. And that can be the very first thing we do. So let's set the colour as a random colour. So just set the colour for the whole animation to be a random colour, and then we can use this colour when we make our circle, our line, and then our finishing circle. So let's finish with, let's start with the first circle. So I'll do var circle, that would be a basic circle, equals new basic circle. And then in there, again we need a radius, a colour and a time, but this time we have the colour already done. So we can still do a random radius. Let's go with something maybe a bit smaller than the last one, so let's do 20 plus math.random times 20. And then we'll use our colour and we'll do a random time, so maybe a bit longer than the other one, 20 plus math.random times 20. So we've got a circle made. Let's do the same thing we did in our basic animation by adding an event listener to it. So add event listener, shape complete, and instead of finishing the animation there, we're going to go on to the next step. So we'll do a draw line function. So we've done the first circle, and now we want to go on to draw a line. Last little bit, add child, circle. So it's very similar in setup to our parent class there, but instead of finishing when the circle's done, we're actually going to go on to the next step. We're going to draw a line. So we need to put the function in to do that now. So let's do a protected function in case we ever want to override this. Protected function called drawLine, which is responding to an event but doesn't return anything. So make sure event is imported, which it just did for us. And we want to make a line, so let's start by storing it. So I'll do var line, which will be a basic line we haven't used yet, equals new basic line. And now here we hit a bit of a stumbling block because we need an endpoint. So really, before we draw this line, before we make this line here, we need to set this endpoint so we know where we're headed. And this is where we can make use of the endpoint of our class, which we made in the basic animation. So we'll just set the endpoint there because we know this animation is going to end where this line ends. It might have an extra circle at the end, but it's going to end at this point. So we'll use that, we'll set the end. So set the end of the animation here. But how do we do that? Best randomizing it. So we'll randomize an angle and a distance. We'll do that across two variables. So we'll have var for angle, and because we're working in radians, we need to work with math.pi times 2, because that's a full rotation, and times that by math.random. And that will give us a random angle. Get a random distance, and again, play with these numbers. I'm just going to make some up. Let's say a distance of at least 100 and a possible extra 200 on there. So we could go between 1 and 300 pixels in distance. We're then going to set the endpoint by using the angle and the distance and a bit of trigonometry. So we'll do end equals new point. Point's imported for us, yep. Bit of trig, math.cos angle times the distance or the other way around, distance times math dot sine for the y of the angle. So you could have done distance times math dot cosine. I was just flipping them just so you know they mean the same thing, except cosine goes in the x-axis and sine goes y. So we now have the endpoint for our basic line, so we can pass that in. If I just pop the help up again, we need an endpoint, which we now have as end. A line colour, which we also have because we stored it up above. A line thickness, which we can randomise here. So let's say at least 4 pixels, but up to another 16, so anywhere between 4 and 20 or 19. And then a random time again. Let's just copy what we already had for our circle. Paste that, close the line call. We then need an event listener on our line and we need to add it to the world. So I'm going to copy these 2 lines and just change circle to line. Instead of drawing line, we could finish here, or, well, should we finish here? I know I'm waffling on. You might get the idea of how to add the extra circle, and I will probably come back and add it in, but let's finish it there. Notice we don't need to make the finishing function because it's already in our superclass there, so we don't need to worry about making that again. It's just going to do what the parent would do. I really should have left my code in the timeline so we could test it, so let's go and undo it. There it is. So instead of a basic animation, let's have a line animation. Just going to quickly update the code to check it works. We're not going to be working in the timeline, just want to do this to check it works. Yeah, you can see it's working, but we're not spawning the next animation from the endpoint, which is fine. We haven't made the controller for that yet, but as long as our points are working, we're not getting many. Well, there we go, up and left. I was going to say they seem to all be going to the right, but it seems to have fixed itself. I'm going to close it before it lags, but at least it works. Feel free to go and tweak it to have an extra circle on the end. What you might want to do at this point is go back, look at the basic shapes and maybe do some of your own. You could have triangles, squares and so on, have different sorts of shapes, put outlines on them, make different building blocks, because there's no limit to this. When we come to do the controller, it will take any amount of animations you've made. I've just done 2 basic ones to get the video done in a reasonable time, which I realise is already getting quite lengthy. Hopefully it made sense. Post any comments, pause the video, come and nag me for a while, and then we'll go on to part 3 where we start chaining these together and adding music and pulsing and rotation. Right, we're into the home stretch. There's still quite a lot to do, so I'm going to try and pick up the pace and just sort of talk as I code. All I've done since the last video was to delete the timeline code that I had. That was never meant to be there, it was just purely to test that things were working, so make sure you don't have that. Now, what's going to happen is that our document class is going to change a few times throughout this section, just so we can test various stages of the development. And I'm going to actually start that as the controller for our animation. So I'm going to make a class called controller, and it will be the document class for a while. So I'll type that in and generate it. Just going to save it straight away. And then replace these movie clips with sprites. We don't need them to be movie clips. Okay. Also going to give it a few properties that we need to keep tabs on. I'll make these private. There's no reason for these not to be private. I'm not going to extend the class. Private var, and this is going to be called classes, and it's going to be a list. It's going to be an array of possible animations. So let's comment that in. Possible animations in the chain. Going to have another list to remember the animations that are on screen, so we'll call that animations, and this can be an array, or you could, if you want to, could use a vector of basic animations. A vector. You could use a vector of basic animations if you want to. That's basically a typed array. And we're going to, even though it's going to be in the animations list, we're going to store a reference to the last animation that we added, just so we've got it a quick reference, which will be a basic animation. Because all of our animations extend from basic animation, it's okay to use the type as it there. So even if we put a line animation into this variable, it's okay because line extends from basic animation. That's really it for the setup there. Into the constructor, and even though I mentioned how it can throw some problems up later on, I'm actually going to use the added to stage listener. So if we get some problems, we'll try and work around it. And the listener here will just be a function called begin. So we want to begin when this is added to the stage. Okay. We'll set everything up in there. So that's the constructor done. Let's make that private function begin in response to an event. Make sure event is imported. In here we need to sort our classes, so put all possible animation classes into classes list. I'm just going to do this shorthand by doing classes equals and then using square brackets to make an array. So I've only got 2 animations at the moment. You might have made a few more, but I've only got basic animation and line animation. So I'll just add them both in. You can have as many as you want in there. We're going to randomly choose one animation from this list every time. So say you wanted one animation to happen a bit more regularly, what you could do is put it in more than once. So if I want my basic animation to happen twice as often as my line animation, I just make sure that it's got twice the mention in the list, which is what I've done there. Then going to make the animations array, just make it a new array. And then we want to begin, so start animating. And we'll just call a function called next animation there to begin, even though we've already called begin. So that should kick us off. Let's make this next animation, which is actually going to be a sort of recursive function. It's going to make use of itself in a roundabout way. So we'll make private function next animation, and even though we've called it without any additional information there, it is eventually going to respond to an event. It's going to use our custom animation complete event that we've made in our animation classes. So we will put that in there and give it a default of null, just so we can call it as we have there. And this is where the actual control of the animation happens. So there's a few things we need to do here. We need to randomly select an animation. We need to position it. We need to add it to the screen and wait for it to finish. We need to add it to the animations list and make it the last animation. So let's do all of that now. We'll start by randomly selecting an animation from our classes list. And I'll break this into 2 lines. This could be one long line, but I'm going to split the way we calculate the index here. So I'll have var index, and I'll make that an integer so that it rounds itself down, which is exactly what we want it to do, because to generate it we're doing math.random times classes.length. And if you've worked with arrays much, you'll know that the length of the array, if you pass that in as an index, is actually out of bounds, and that's because they start at 0. So if classes here, that has 3 objects in it, so the length is 3, but the index of the last element is actually 2. So this int cast should round this number down, so we never actually reach 3. We'll get either 0, 1 or 2, which is perfect for accessing 0, 1 and 2. We'll then make the animation, which will be a basic animation. We do that by doing a new instance of the class that's in our classes list at the position of index. So because we've got classes in our classes list, we can actually make new instances of them in the same way you would make a new instance of a class, and then put brackets at the end just to keep it consistent with the way we normally make classes. So that should have made an animation for us. We'll find out in a while when we test it. We want to position it. So the first animation that we make, we'll just position at 0, 0. We'll leave that at the default position. But if we already have animations on screen, we need to position this current animation at the end of the last one. So what we'll do here is say if last animation doesn't equal null. So if we have a last animation, you can also just have if last animation. That should do the same check, but I'm going to leave the full version in so we can see what's really going on there. If we have a last animation to work with, we want to position the current animation at the end of it. So we'll do animation.x equals last animation dot x plus last animation dot end dot x. So that's the end property that we put in all of our basic animations, so we know where they finish. And it's always a finish in relation to where it started. So by adding the end to the actual position, we get the first position of our new animation. Do the same in the y. Could just paste it. Let's copy that. Paste it, update the x's, and that's it positioned. You then need to add it to the screen. Easy bit, add child, animation, and listen out for it finishing. So we want to add an event listener to it. So we'll do animation dot add event listener, and here we'll listen out for the animation complete event that we made up, and we want to actually call this function again. So it's basically making this function recursive. It's going to make use of itself over and over again to consistently spawn animations. So we'll put next animation in there. Then we want to add it to the animations list and make it the last animation. So we just do animations.push animation to add it to the list, and we set last animation to match animation, to store a reference to that animation we've just made. So the last animation becomes the one we've just made. And if we save that and make sure it's set as our document class and test the file, whoops, typed something wrong. Where are we? Oh, I did a colon instead of a semicolon. We can see that we start, and luckily enough, the first animation came down before it went back, but because of the way we're positioned at the moment, because our controller isn't really the main object in our world, we're not focused on it. So you can sort of see it started up there. Hopefully if I stretch it we can see that it's been doing a load of stuff. But I'm going to close it before it lags. The important part is that it's chaining together and starting the next animation from where the last one left off, which is perfect. That's just what we wanted. We do have issue in that we're not following it though, so let's quickly just allow this controller to track the animation. So underneath the next animation call there, I'm going to say start tracking the animation. And this still won't be perfect because we're still not the main focus of the file at the moment, but we will simulate the effect of following it. To do that, I'm going to add an event listener, event.enterFrame. So every frame we're going to focus this controller on our animation. So that requires a new function. Make a private function called focus in response to an event. No return type. Make sure I stick with that. Okay, so we want to pretty much zoom to the position of the current animation. And we can do that by snapping to it. If we do x equals minus last animation dot x, y equals minus last animation dot y, that will have the following effect. It'll always be in the top left, so the way it's running at the moment, if we stretch it out, we do snap to the next position, but it's always the top left because we're positioned at 0, 0 at the start. We will fix it, don't worry, but we can see that we're moving with the animation in a roundabout way. It's very jerky though, I don't want that, I want to do it smoothly. So let's change the logic of this a bit. Instead of snapping to it, we'll gradually add a little bit to our x and y position so that we move towards it. So we know this is where we want to be. We want to be at last animation.x. That's where we want to be, or minus last animation.x. If we put that in brackets and take our current x away from it, that gives us the difference. And do the same with the y. That gives us the difference from where we are compared to where we want to be. If we times that by a small number like 0.1, so 10%, that means we're going to cover 10% of the difference every frame instead. So let's try that. And you can see instead of snapping to it, we're actually smoothly following it. Still not quite ideal in terms of centered on screen, but we are moving with the animation, maybe a step behind. So what we can do is use the end position as well. So let's have a think. Minus last animation.x. Let's do minus last animation.end.x. And then same in the y, minus last animation.end.y. Try that. So that should hopefully make us one step ahead. Instead of following the line after the line's been drawn, yeah, we move as it's being drawn. So that's perfect now. That is pretty much complete for this class, other than deleting the old animations, because it will get very laggy very quickly. So we'll do that underneath. We'll delete the old animations, or fade them out. So it's going to require a for loop. We'll have a for loop, make a variable, we'll call it I to count through. It's going to be an integer, and we're going to set it to be animations.length -1. So we want to get the last index of this animations array. We're then going to work through the loop while I is greater than or equal to 0. So we're counting down, which means we need I minus minus there. And all we want to do is lower the alpha. So we'll do animations I, we're getting the index at I, the object at index I, dot alpha minus equals, and then you want a small number. So alpha goes between 0 and 1. If we take 2% of that alpha off every frame, it will fade out across 50 frames. We then need a check. Let's say if animations I.alpha is less than or equal to 0, we want to remove it. So we'll remove child animations I, and we'll splice it out of the list as well. So animations.splice. We want to remove starting from index I, and we just want to get rid of one element, one object in that list. And if we test that now, you see a little problem in that we're getting rid of them pretty much straight away. Or we're getting rid of them straight away. That's not really what we want. We want some of them to stay. So what I added into the original was a grace period, which I took off this I variable. So we've got I equals animation.length -1. I then did a constant called grace period, which I also took away. And this grace period represents how many objects you want to be on screen, how many you want to stay. So we need to make this up near the top. Let's make a private const and call it grace period. And I'm going to set it to 10. So we have 10 animations before they start fading out. Save it and try it again. We should see that they don't delete straight away. Hopefully we'll still be in range when they start to delete. This one should go soon. Yeah. So after 10 animations are on screen, the oldest ones start to be deleted, which is perfect. And that is our controller class finished. We can now use that inside of our music controller class to do the visuals while we handle the music and the pulsing and so on, which we'll crack on with now. And just to check that's working, we're going to come back to our FLA, and I'm going to change the document class again, and I'm going to call it Pulsar. So I'm going to make a class called Pulsar, which handles the music and the response to it, and I keep doing hand signals that you can't see, so I'll stop that. Make that class, don't worry about the code, just save it, because we're going to replace it with an Adobe example. So I've just saved that in there, and I've got my internet browser open, and I've been to Google and I've searched AS3 Sound Mixer, and this is the class that does the magic really. So this is what you're presented with if you've found the right place. And we're interested in the compute spectrum method. So if you find that in the public methods and click on it, you'll be taken to the explanation of that function. So feel free to read through that. I'm not here to give you the information that's already there. You can read that straight from it. But what I am interested in is their demo of it, which even in its own right is pretty freaking awesome. So we're going to copy that, go back to Flash, and just to show you what it does, I'm going to replace my entire Pulsar code with it, paste it straight in, and just rename the class to Pulsar. Rename the constructor as well. So I've got public class Pulsar and public function Pulsar. We need a song as well to work with. The demo assumes you've got song1.mp3 in the same place as your class file. What I've got two pieces of music. I've got Cut and Run by Kevin MacLeod, which was in the original demo that you might have seen. But I've also got a piece of music by a friend of mine called Sam, who you should totally check out. I'm not pushing his website or anything, but it's fishermusic.co.uk. And there he is, looking all thoughtful with his saxophone thingy. That's him. He's provided the music for this one, and does for quite a lot of my stuff. I think he did the music for the Point Click Win series. Bug him for music, I suppose, if you want. That's him pushed. Right, so we're going to use his song, and it's called Gem. Gem.mp3. It's in the same place as this Pulsar file. So I'm just going to save it and show you what that does. This is Adobe's example. I haven't made this. But I think you'll agree that is pretty impressive, to say it's not much code. So what that example does, it takes the compute spectrum function and it turns it into a visualization of any sound that you're playing, which is great. You might want to just use that in its own right somewhere, but we're not here to do that. So I'm actually going to chop it apart a bit and adapt it for our own needs. So we're going to start with this class, keep it structured the same, but we're just going to rejig it a bit and change it to control the scale instead of drawing our sound. So a few changes I'm going to make. Here in the constructor, I'm actually going to cut this var snd sound, cut that out, and just replace it with snd, and then we'll make the sound variable available at class level so we can have access to it in other functions. I'm going to make it all private. I don't think I'm going to be extending this class, so it can stay private. I'm going to do the same with the sound channel down here. So instead of making the channel there, I'm going to make it class level. And I actually don't want to load the sound externally. I want it to be embedded in my SWF. I don't want to have to upload sounds and flash files. So I'm going to change the way this works. We're not going to use a URL request. I'm actually going to use a flex command to embed the sound. So first line inside this class, I'm going to use square brackets and type embed, then open regular brackets and do source equals, and then in quotes the file name that you want to embed, which in this case is gem.mp3, close both sets of brackets, and then straight away on a new line you need to make a variable to store this class. So I'm going to make a private var called gem, and it will be of type class. So it's going to be basically a sound class that plays that song you've just heard. So now instead of making this sound and then loading it in externally, I'm going to delete these two lines and replace new sound with new gem, because that's the name we've given it here. And let's just check it works at this point. Yeah. If you get an error message that pops up there, it'll just want you to update your flex links. Just press update or press OK and then retest your file and it should work. But we're up and running now. Just before we get into the meat of what this class is really doing, we've got an event listener that every frame is going to call this onEnterFrame function, which is down here, and we've added an event listener, or Adobe have added an event listener to this sound channel, which is generated when we play our gen music. And it's got a function called onPlaybackComplete, which is down at the bottom. And what their function does is removes the event listener and stops the update, which I don't actually want it to do. I want it to play the sound again when the sound's finished. So I'm going to delete that, come back up here to where we make the sound and to where we add an event listener to it. So I'm going to copy those 3 lines, come back down to the bottom, paste them in and just get rid of this enter frame one. We don't need to re-add that. So when the sound finishes on playback complete, I'm going to tell it to play again and tell it to respond to being finished again, so that it infinitely loops effectively. Right, let's get into the real genius of this class. This is what Adobe have done. This is entirely their example. I'm not taking any credit for it, but what I have been doing is ripping it apart to satisfy what I wanted to do. At present, what it does is makes a variable called bytes, which is of type byte array, which is literally an array of bytes, an array of bits of memory that we eventually use in this sound mixer. It then has a plot height, which is basically the maximum height the wave can take in its graphical form, which we don't need. We're not doing any graphics, so I'm going to delete that. It has a channel length, which is the amount of samples in each channel of the sound, and we can change this later on. We might drop the quality of the sample sound. We don't need to be sampling it at the highest quality for our purposes, but depending on time, we might just leave it as it is. It then uses the method that the example was made to demonstrate, which is the compute spectrum method of the sound mixer class, which lets you pass in a byte array, so bytes there is passed in, lets you decide if you're doing a sort of transform. I'm no expert on sound, so I have literally no idea what changing that to false does. And then it lets you specify the level or the quality of the sound sampling. So 0 is the best quality, it's 44K, I think. We'll leave it at that for now. Like I said, we can change that. If you put that to 1, it halves it. Put it to 2, it halves it again. It then goes into graphical stuff, which I really don't want. So any line that features G, the graphics aspect, I'm getting rid of. I don't want it. We're not working with the graphics. There's a line with G. Let's get rid of that. And there's lots of lines with G. Let's get rid of all of them. Another one. And another 2 to finish there. So got rid of quite a lot there. We've trimmed it down so it actually fits on one page. There's still more trimming to do. What we've got here is a number. What we're going to use it for is to have a running total of every sample's value. So we're going to tot up the value of all the samples and then get an average. So let's just change it to a more meaningful name. Instead of n, I'm going to use scalar. Then in this for loop, what it does, this is for the left channel. This loops through based on this channel length, which will go basically half of the length of the byte array it's set up to do. We're actually going to get rid of one of these for loops and just double the channel length, so we do it all in one go. But what they did was, to draw the left channel in a different colour, they had 2 for loops, and then the right channel in a different colour. We don't need that, so I'm actually just going to delete the second for loop. And then it used the read float method of the byte array times the plot height to get a position graphically to draw. We don't need that, we just need the read float part. So we're taking a floating point number out of that byte array as a value for the sound sample at that particular point. Hopefully that makes some sense. Like I said, I'm no sound expert, so I'm probably not explaining it all too well, but there are so many samples in this particular loop, so many values, and we're just taking them all and we're going to get an average of them in our scalar value. So instead of using n, I'm going to use scalar, and instead of setting it to equal this read float, I'm actually going to add the float to it. So we get a total of bytes, a total of, not bytes, get a total of the floating point numbers read out of this byte array. What we're then going to do after the for loop, we're going to average the scalar. So we've actually added 256 numbers together there, or rather we should double that now because we're only doing one for loop. Let's double it. Doubled it up to 512, so we get every number. And we're going to average the scalar by doing scalar divided by channel length. And that will give us our average scalar. Under that then we'll set the scale. So set the scale based on the scalar. So we'll just do scale x equals scale y equals 1, and then we'll use the scalar to affect that. So we'll just, for now, we'll just do plus scalar. So we're going for the standard scale plus whatever we've generated with scalar. And my FLA here has magically changed just to have some content to be able to tell if it's working. I don't know why I've set the background to red, but we've got an object on screen just so we can see if it's scaling. You don't need that, just make sure that your pulsar class is saved and make sure it compiles, really, that's all we're after. But I just want to check that it actually moves, so when the music kicks in, there we go, you can see that it's scaling. It's a bit jerky though, and that's because here, where we're using these floating point numbers, the values of those samples are actually between 1 and -1, so a lot of them will just cancel each other out. To get something a bit smoother, we can make sure we're just working with the positive version of those numbers by doing math.abs around that. Make sure it's all in brackets, and if we save that, that should be smoother now. There you go. So that was definitely working. Yeah. That's really it in terms of the base logic of how I did the pulsing. I did do a bit of fancy stuff in here, which we'll come back to. But let's get it all up and running together. So I'm going to go back to my FLA, delete what I've got there, and for the last time I'm going to change the document class, and this is where we settle on main. So I'm going to make a document class that matches the flash file, so we know this is the one, this is the boy. Let's make that. Doesn't need to be a movie clip still. Let's set it as a sprite and save it. I'm not sure we need imports. We're just going to use this as a frame for our pulsar and our controller. So here in the constructor, we'll comment it. We'll add a pulsar and add a controller to the pulsar. Just go lowercase. Make a pulsar and then we'll add a controller to the pulsar, and this is where we can rectify the offset of the controller so it can be centered on screen. So we'll make var pulse of type pulsar equals new pulsar. Position it, so we'll do pulse.x equals stage.stage width over 2. Pulse.y equals stage.stage height over 2. So some consistent spacing. And then we need to add a new controller to it. So if we just do pulse.addChild new controller, and this is what was giving me the added to stage problems. So I added the controller to pulse, and then I added pulse to the screen. And let's see if that works. Remarkably, it's working, so we didn't get the errors I was having. Everything seems to be stitching together properly, and because of the way we've positioned the pulsar and the way we've set the controller, we're actually centered on it the whole time. The scaling doesn't happen from the top left, it happens from the dead center. That's because the pulsar is actually positioned here in the middle of the screen, and the controller is centered around that, so it scales outwards from there rather than from the top left. Yeah, that's it. That's the main core of it all. I think I did say I'd go back to the pulsar and maybe change this a little bit. So I did an extra tween or two to make some extra effects. So I didn't actually do the scaling exactly like this. I had a base scale, so let's do that. Let's have a base scale. And instead of starting from 1, we started from this base scale, and then we plussed scalar times base scale. Scalar times base scale plus the original base scales, and this was anywhere from 0.3 to 3, so we could zoom in and out. So we'll come up to the top and we'll make that. We'll do private var base scale That will be a number. In the constructor, we'll just set it to 1. And then we'll start tweening it as well. So we're going to need some tween resources. Do private var scale tween. Or maybe have a rotation tween if we've got time. We've imported tween. We also need to import tween event and the easing. Instead of fl.transitions.tween, we need the easing, just as we did in the earlier bits. Use a tween system if you want, if you've got one in mind. Scale tween of type tween, and then when we start this pulsar, we're going to make that tween. So let's do, let's actually do it in a function. So we'll do tween scale, and make that function. So private function tween scale, which is in response to a tween event, but to be able to call it like that we need the null, as we've done before. No return. And in here we're going to set up the tween so it loops indefinitely, it'll keep coming back to it. So we'll do scale tween equals new tween, and in there we're tweening this object, and we're tweening the base scale, was it? Now we're going to hit a stumbling block because I've made base scale private, but let's just get that error so we can see it. We need the easing function. I'm just going for regular dot easing out. We'll start with the actual value of it, so we'll start with what base scale is, and we'll tween it from anywhere between, just do this on a new line so it's easier to read, anywhere between say 0.3 and plus math.random times 2. So anywhere between 0.3 and 2.3, I suppose. And then a time, random time, let's say 100 plus math.random times 200. So it could take between 1 and 300 frames to do this animation. Last step, let's add an event listener to it. Scale tween dot add event listener. Tween event dot motion finish, and we want to call this tween scale function again, so that this loops endlessly. We'll just run it and get that error, because you can see there that our tween cannot create the property on our pulsar class because this is a private variable. It can't access it or manipulate it or create it because it already exists but it's private. So let's change that to public. Pubic. It's a bit vulgarant. Let's save that. Try it again. And hopefully the scale will do something. There you go, we've just zoomed out, so we're at a smaller base scale, and we're zooming in a bit. See, we're very close there, so it's obviously got to be a bigger number, and I'm sure it'll zoom out again in a second. We've come back a bit. Looks like we're going back in. Come on, come out. Zoom out. It's been stubborn, but it's definitely changing. Yeah, there we go, zoomed out a bit. Yeah, so it's working. And what I also have been doing while I've been playing around is duplicating these and making them affect the rotation. So let's do, instead of a, we don't need a base rotation. Instead of a scale tween, let's have a rotation tween. And we'll also do tween rotation. Might as well copy the function, paste it underneath itself, change it to tween rotation, and instead of tweening the base scale, we're going to tween the rotation of the class, and instead of using base scale there, we'll use rotation. Change the random number a bit. You won't notice that rotation there. 2 degrees rotation is nothing, so we'll actually go with 360 minus math.random times 720, so it could rotate 360 degrees either way. The time of that tween is fine, I think. Instead of having it as scale tween, that needs to be rotation tween. Rotation tween, and tween rotation instead of tween scale. So make sure any reference to scale in this function has been edited out. let's give that a go. So we should also be spinning as we're scaling and animating and playing the music and pulsing to the music. We've got all sorts of stuff going on. And there you have it. That's pretty much everything I put in there. I know there's a coloured background, but I'm sure you can figure that out. Tweening colour value pretty much the same way I've done the rotation and the base scale there. So enjoy that. Let's see what you can make with it. Make some different basic shapes, some different types of animation chain. Just show me what you can do. People don't show me enough stuff, I think. Considering how many people actually view these things, I get shockingly few end results, and I want to see them, so do show me. Bye for now.